Okay guys, so welcome to this video 3.10, equations review. So what we're going to do in this one is quickly look at some of the things that hopefully you've had a chance to look at and remember from last year in grade 7 and sort of build some foundation for our work with equations, which is probably the pointy end of your algebra study this year. So a couple of definition things. An equation, this thing here, is a mathematical statement involving two expressions and a relational symbol, usually equals, although we can also have greater thans or less thans, and etc. If both sides of an equation are exactly the same, we say it is a true equation. If there are variables in an equation, we can find solutions that satisfy this equation. So that's something we'll be looking at doing. And if you choose to go further on in maths and maybe in some of the sciences, certainly there's a lot of it is involving this idea of constructing algebraic expressions and equations and solving them. Okay, so a couple of things that we need to know is that an equation can be true or false. Actually, I just want to quickly say that with our equations, the way I want you to think about it, and this may help a lot of you, I want you to think about it that similar to a set of scales, okay, and let's just say we've got the equal sign in here, is that the stuff on this side and the stuff on this side are exactly the same. Okay, so whenever we do things in algebra, whatever is done on this side here gets done to this side here, because we're always going to have our both sides being the same. Okay, obviously we're going to be looking at untrue and true statements in this video, but once we move on from that, we're going to be keeping this idea of things being the same on both sides. Okay, so an equation can be true or false. So a couple of ways we can demonstrate that is create, say, 3 plus 4 equals 7. So this is a true statement. Okay, yay. You could do 20 times 3 equals 61. Well, that is an untrue statement. Okay. You could, however, say that 20 times 3 is not equal to 61. That would be a true statement though. Okay, so you can make untrue statements true by changing this thing in here, your relational symbol. Okay, so this thing here is your relational symbol. And remember that this sort of means that the stuff on here, is the same value as the stuff here. Okay, right. Equations have a left-hand side and a right-hand side. So let's sort of just write an equation here. I might choose to do 4x plus 18 is equal to 26. Okay, so when we're looking at something like that, sort of imagine there's a wall, divide there, and everything on this side is the left-hand side, and everything here is the right-hand side. Okay, so it's important that you know those terms and can refer to them, because later on when you're doing more complex algebra, you need to do things to one side and the other and prove different things. Okay, and essentially there's this idea that whatever gets done to this side also gets done to this side. Okay, but we'll look at that a bit later. Okay, a solution to an equation is a value that satisfies the equation. Solutions are found by solving an equation. So for instance, if we had 2 plus some number is equal to 3, well, it's pretty obvious that 2 plus something is 3. Okay, well, in this instance we might say that x is equal to 1. Okay, this is the solution that satisfies this. Okay, and we can test solutions by substituting them back in. So let's just check that. 2 plus 1 is equal to 3. Yay, that's a correct statement. Good times. Okay, right. Couple of worked examples. You might notice I'm trying to get through this reasonably quickly. That's because I'm well aware of many of the videos sort of getting a bit long, and I don't want to spend a lot of time in this stuff that should hopefully be revision for many of you. if not all of you. Okay, here's some worked examples. If x is equal to 25, is this equation here true? Alright, so I'll show you how we test that. So as I demonstrated before, we can check whether a statement is true by substituting our value and see if we have a true statement. Alright, so x minus 4 over 3 equals, we're going to substitute our x is 25, so 25 minus 4 over 3, 25 minus 4 is 21 over 3 is equal to 7, which is equal to the right hand side, which is great. Okay, so remember that idea of this is the left hand side, this is the right hand side. So I work through and it equals 7, which is equal to the right hand side, which makes it a true statement. Okay, let's have a look at this next one. If v is equal to 8, this is the equation 4 times 5 minus v equals 12 true? Well, let's have a look. 4, 5 minus v equals, let's substitute 8 in there. So 4, 5 minus 8. Now you may be already starting to see what's going to happen here. So we could distribute this, but since we've got all our numbers inside this brackets here, we may as well just calculate it. So 5 minus 8 is negative 3. 4 times negative 3. 4 times negative 3 is negative 12. Which is not equal to 12, so therefore untrue. Okay, you might even write not equal to right hand side. Okay, so it's untrue. We won't be doing a lot of these things, but it's more about getting an idea that one side's the same as the other and true and untrue statements. Okay? Okay, write an equation to represent this statement. Now, these ones here are stuff that you need to get well practiced at. 2 reasons. First, and probably something you're more concerned about right now, is that your exam and the maps problem solving stuff especially will have some of these. Okay, I can tell you that without a doubt. Additionally, algebra is one of the more powerful problem solving tools that you will ever learn. Okay, and if you're able to turn a descriptive sentence into a number sentence, a whole world of possibilities opens up for you for solving particular problems. So let's have a look at some of these more basic ones and see how we go. Right, write an equation to represent this statement. The sum of 6 and some number is multiplied by 8 to give a result of 0. Well, first off, what I'm going to do is sort of suggest that this number here, I'm just going to make this x. Okay, sort of look for these cues. A number, some number that we don't know already. Let's just make it x, y, z, doesn't matter. Any letter. You can make it squiggles, but probably letters. Let's just stick with that. Okay. Other things to unpack here. The sum. So we know that we're going to have a plus somewhere. So we're going to add these two numbers together and then multiply by 8. Okay. So the sum of 6 and some number is multiplied by 8. Now, it's the key thing here is the sum of 6 and the numbers multiplied by 8. So this has to happen first. So we're going to put that in brackets and we're going to multiply it by 8. You can put it at the front or the back, doesn't matter. Chuck it at the front to give a result of 0. So we know that the stuff on this side is going to have to be the same as 0. And we're done. Okay? So hopefully we're sort of able to follow that. Please rewind, watch it again to see how I sort of unpack that number sentence there. Okay, now here's a bit more of a difficult one. This is probably more like what you're likely to see on an exam or need to solve in any kind of problem solving situation, okay? Remembering that the more you do algebra, your brain will actually start to change and make new connections inside it to sort of enable you to work with these things more easily. So, let's have a look what we've got here. A school wants to take an excursion of 25 students and 2 staff to the zoo. Okay, so I know we've got, so here's something, here's a key idea, 25 students, 2 staff. The bus will cost $150, okay? And the zoo admission is $8 per person. Right, a good way to start this off would be like, well, let's just put a question here. What is the total cost? Okay, right, well, let's write a number sentence. Whenever you're solving these problems, rather, like if you can't go straight to the numbers in the algebra straight away, write out a number sentence. Okay, so our total cost of our trip is equal to the price of admission plus the cost of the bus. Okay, all right, well, we know this. We know that the bus is $150. Okay, so we can straight away write that. Okay, so you can sort of see how that just goes straight down to that. Now, next one here, let's work on this. The price of admission. Well, the price of admission is going to be the number of people multiplied by the price. Okay, all right, well, where's our price? Our price is X dollars per person. And our number of people is 2 staff and 25 students. So, the number of people is 2 plus 25 times the price is X dollars plus 150. Okay, so as you can see, this sort of came straight down to there, that came straight down to here, this just keeps going straight down that way. Okay, let's polish this off a little bit, make it look a little nicer. Right, 2 plus 25, both numbers, we can just add them together. So we've got 27x plus 150. Sort of this has become that. And our cost of the trip is equal to 27x plus 150. So there's those steps I've gone for. I really encourage you to do up a number sentence like this at the start, especially while you're sort of just learning this process of creating an algebraic model. That's what this is, okay? You can use this algebraic model no matter what the price is, even if it changes per day, okay? Because we have a price that is variable, okay? This indicates a variable price, okay? Please watch some of those examples again if you didn't quite get them, and come along to class with any questions so that we can go through them before we get started into the work. Okay? Thank you for watching.